Hello, everybody. Happy Friday. It's great to be in San Jose. I am going to talk about building a collaborative ecosystem. And as Bill mentioned, um, collaborative ecosystems, um, talking about OCP, very, very familiar with collaborative ecosystems for hyperscale data centers. Shifting gears to the edge is something that we're going to take a look at today. I'm going to talk about what I'm seeing. OCP is going to talk about some programs that they have actually in the works already. So why is this important? If you looked at the sales data and the projections, the OCP at the edge is actually going to be a larger market than hyperscale data centers in a few years. Think about that. This conference is going to be actually turned upside down in a few years, potentially. Everyone's talking about hyperscale. Focus is going to be more on the edge. So what's driving things to the edge? In my opinion, there's three things driving to the edge. Number one, reduced latency is needed. There's too much jitter, there's too much freezing, there's too much slow performance. What else is needed? There's a tremendous amount of data being generated that has to be processed. There's a tremendous amount of content that has to be delivered. And number three, there's new technologies coming out, namely 5G, that are going to be highly dependent on edge data centers. So we're talking about a collaborative ecosystem. Exactly what does that mean? It starts with hardware, software, people all working together. When you're all working together, you need some processes around that. Once you have processes, you need some systems to put those processes in. Then you need some overall governance. So that's things we're hoping to build for a collaborative ecosystem at the edge. So here's a simplified view of cloud data center architecture that I think everybody is pretty familiar with. You have the large hyperscale centralized data centers that have traditionally been the workhorse, of the cloud world. I'm not saying this market is going to slow down. The projection is the capacity, compute capacity in these hyperscale data centers is going to double in the next couple of years. So a tremendous amount of investment in these hyperscale data centers. But you are seeing the applications, the cloud services moving into regional data centers in urban areas, mainly to reduce latency and improve performance. What you're going to see is an even farther move, closer to the people, closer to the data, in local edge. So you're going to see cloud stacks, cloudettes, outposts, whatever you want to call them. So the idea is that these cloud services are going to be hosted in this whole complex architecture, and you're not really going to know, as the consumer of these cloud services, where they're being hosted. If there's lower latency, you could probably assume that it's maybe in a local edge site. So that's the cloud computing architecture. If you look at what's going to happen with Telecom, Telecom is actually going to build an architecture that's almost identical to this. They call it a little bit different. They call it the core and the edge. The difference is the data centers on the edge are going to be what they call MEC. And MEC started as the acronym for multi-access edge computing for Telecom. And what that meant is you're going to have a small data center that's going to be able to deliver in multiple different ways, whether it's fiber, whether it's a radio network, 4G or 5G, through Wi-Fi. But MEC is really changing, and the definition is really migrating towards mobile edge computing. So you're going to see mobile edge computing, and when we're talking about 5G rollouts, we're talking about a tremendous amount of capacity. There's projects that are going on right now for 10,000 pieces of these local edge data centers. They're planning to stick these in parking lots, on top of buildings. 5G does not have the range that advanced 4G has. So the idea, though, is not to wait for the 5G technology, which is highly virtualized, to be played up and fully developed. They've disaggregated the hardware and the software in these local edge MEC data centers, so they're going to be rolled out initially as 4G LTE, and then once the software is ready for 5G, they're going to put those on those systems. So those are the main applications. You're also going to see AI move to the local edge. It doesn't make sense to process, a tremendous amount of data. AI is very processing intensive, so we're going to see that moving closer to the edge. We're going to see IoT applications. Manufacturing is a good one, and since we're in California, we're close to Napa, there's vineyards that are actually deploying local edge data centers and have thousands and thousands of sensors and data that they're reporting. So these are the applications that we're gonna see moving to the local edge. So I think most people are familiar with tier levels. Tier levels are kind of the way that the data centers have been rated for availability. And most data centers are built at tier 3 plus that are what you call critical data centers, critical applications. This equates to about 1.5 hours of downtime a year, or every 3 years you may have an outage for a few hours. And this is actually pretty good designing with this type of availability. The tendency, though, when you're doing smaller data centers is to say, oh, well, since they're smaller, they may not be as critical. But we're seeing critical applications moving closer to the edge. So we actually have a white paper on this, and you could review all of the math if you're interested. It usually, when you have an architecture that's hybrid of centralized data centers and local edge data centers, it kind of defaults to the lowest availability. So instead of having 1.5 hours of downtime a year, it shoots way up to about 31 hours of downtime a year. So think about that. Think about an application, maybe it's a hotel, and the systems are down, or a restaurant, the system's down. The hotel, you get there, the systems are down. They're basically crippled. You would think they would have like LTE backup to be able to communicate with their systems, their corporate systems, but they're really not there. And if you've ever, and it's happened to me a few times, I've been there, you have to wait for the systems to come back up. So key takeaway is when you're architecting an architecture for cloud data centers, that make sure that the edge is resilient. And that's what we're going to talk about. How do we make the edge more resilient? There's 3 ways: an integrated ecosystem, management tools. Management tools have to be tailored to the edge. The old management tools that we use for single data centers are not going to be good for edge data centers. And then analytics and AI. When you're deploying at scale, say you have 200, 500, 2,500 deployments, the analytics and being warned before something's about to fail is extremely important and critical. So let's talk about the integrated ecosystem, and as we talked about earlier, a collaborative integrated ecosystem. So the challenges are, like I talked about, many sites. In the past, you may have had a few sites or one site, but now you can have thousands of sites that you're going to have to manage. And these sites, for the most part, are not going to have on-site IT staff or troubleshooting staff. Think of the vineyard I talked about. The odds of having somebody that has an IT background that's going to be able to troubleshoot is probably going to be pretty rare. So it all starts with the customer. This ecosystem starts with the customer. The customer has a problem they're trying to solve, or the customer has an opportunity they're trying to take advantage of. So they usually funnel that to an IT vendor. An IT vendor will say, all right, we'll have these applications, and this is the equipment that we're going to need to run those applications. The IT equipment manufacturer will then talk to the physical infrastructure vendors and say, here's the equipment we need to house. We need to talk about, how available. Like I said, you don't want to make it a tier 1. You probably make it a tier 2 or tier 3. What's needed. And then you talk to the system integrators. The system integrators are going to be the ones that are going to be responsible for putting it together, either putting it together on site or putting it together in a factory, putting it in chalk packaging and shipping it to the site. And then once everything is put together and deployed on site, somebody has to make sure that it's running correctly and is meeting its availability targets. These could be managed service providers. So here you see the complex network of this collaborative ecosystem for the edge. So APIs are great. Everybody loves APIs. The most famous API probably is the Google Maps API. If you're a small business, say you're a pizza chain, you could put a map and say, here's my 10 restaurants. Or you can interface with Google Maps, and you could click on the location, and then the customer will have guidance to your different restaurants. And you could tweak it and make it look like a little bit different than the standard Google Map interface. Google, I don't want to get into the politics of it, but Google, they have value because they have data associated with what the customers are doing. And, they could use it for themselves. Pizza Hut may be interested in that data. Groupon may be interested in that data. But we're not talking about an initial API for the edge that's that advanced. We want to start with an API that just brings the data to the service providers or whoever's going to be keeping these data centers up and running. So we want to have things like power, we want battery age, we want temperature. We want to aggregate the data and make the data available. In the future, we'll probably advance it to more of a graphical kind of an interface like a Google Maps, where they'll be able to pick and choose things more easily. But we have to start. We have to get all the data in a format and send it to the customer. And make it available as an API, as an industry API or a standard API as it's called, so that the customers can start using it. So here's something that the industry really needs to work towards. And there's some examples of this in the industry already, but these are fully integrated micro data centers for the edge. So these include all of the IT hardware, the servers, the networking, the storage, that has all of the security, the rack access, the environmental monitoring. So you have smoke detection, you have heat detection, smoke detection. Then you have all the physical infrastructure, the UPSs, the racks, things like that. This enclosure, if you look at it, it may look like a standard rack, but this is actually a 6U rack that's turned sideways. So this is a solution, and we think it's going to start with these smaller applications that are going to be more integrated and standardized. So this is a workload-ready solution that includes everything that I talked about. And this could be for applications like process automation. It could be for a retail store. It could be for a fast food chain. It could be for a process automation. It could be for a small cell site with 4.5G or 5G. So the applications for this are pretty limitless. And when we first started, micro data center talk a few years ago, we were talking 1 rack systems, 2 rack systems, but the applications and the computing capacity has really shrunk these requirements. So this actually is 6, like I said, a 6U integrated micro data center. So management tools, I talked about. You could do a dedicated management tool for every site that you have. It wouldn't be inefficient. It would be very inefficient, and it really would be hard to keep updated. So conventional management tools are really inadequate for the edge. You have way too many sites. So what you want to do is you want to design a system that keeps your site secure and gives you warning if things go wrong, or if possible, gives you advance warning if things go wrong. Getting advance warning is not just, hey, it's about to overheat and it's going to overheat in like 5 seconds. It's, hey, this has, been operating very close to its limits, and we recommend this. So if you have this many sites, it's really important that you're not bombarded with a lot of nuisance messages. You want only messages that are actionable. So the old paradigm, and each piece of equipment within the micro data center on the edge would have its own IP address. It would have its own way of communicating. It would have its each one would basically say, here's my IP address, and you would have to go look up where is that located, and which facility is it in, and what's it doing, what else is associated with that in the micro data center. The new paradigm is you get a message that says, it's this micro data center, this is where I am, this is the configuration, and this is what's wrong. So we want to move towards this more of a simplified management for the edge applications. So having these tools cloud-based, I think, is really important. Having them cloud-based, you have an app, you have a website you can go to where everything is aggregated and in a format that you can understand. You can access it from any of your devices that you wish to use, a tablet, a cell phone, a computer. You don't, have to be on site. You could look at all of your installed base the way that you want it. You don't have to buy everything up front. In the old days, you had to buy licenses, and you had to anticipate, oh, I do a 5,000, I do a 10,000 piece license. Now you just do them individually, each site. You add it as you grow. And up-to-date cybersecurity. Having the data cloud-based, I mean, it's public that Microsoft spends $1 billion a year on cybersecurity for Azure. So if all the data is being housed in Azure, it's pretty good bet that that's going to be a secure site. Now we want to talk about analytics and artificial intelligence. I think it's pretty clear that the system has to be cloud-based. The other thing that's very important is the data is normalized. When I say normalized, the data could be coded that's coming out in different ways. Like a PDU, for example, it may be coded, one PDU, it may be coded as AMP, the other one may be coded as current, maybe coded different ways. So you have to normalize all that data. The data can also be reported in different intervals. Some things may report every second, some may report every 5 seconds, some may report every minute. So we have to develop a system where the data is normalized and it's presented to the customer in a way that it's rationalized and it's easy to access. And then the data lake. The data lake needs to hold massive amounts of data. So the more data that we have, the more specific and accurate that you can get with the analytics. A talent pool of subject matter experts with knowledge of system behavior. If you do have 2,500 sites and you deploy them, there's a good bet that you're not going to have a failure for maybe a year, maybe 2 years, maybe 3 years. So how are you supposed to, analyze system behavior or do predictive analytics when you haven't had a failure? So you have to start with somewhere. You have to start with people that understand and have a pretty good idea of the reliability and longevity of certain systems, and then you can start there. Otherwise, you'll just be collecting data, and you won't have anything to build your predictive analytics on. Machine learning and algorithm expertise. This is actually the easiest part of AI. Everyone seems to migrate to this and say, oh, we need a complex algorithm. There's lots of complex algorithms. There's lots of people with an algorithm. The hardest part is getting the data in the form that you can put into the algorithm and then starting, like I said, with system behavior and having a place to jump off from. So the foundation is critical. You have to have a secure cloud architecture. You have to have a large data lake with normalized data. You have to have the subject matter experts. And then you have to have the algorithms that you can use in the system. So one of the parts of the collaborative ecosystem that's going to benefit the user is the fact that there's going to be a lot of data being collected across the industry. So like I said, if you have 2,500 sites, you may not have the ability to do some benchmarking. But the collaborative ecosystem of all the partners, we have 100,000 sites, millions of sites. So we'll be generating all of this data, and we'll be able to have benchmarks. And the benchmarks are going to be things like, temperature. There's of the million micro data centers that are out there, 87% of them are running below this temperature, and the ones that are running, at this temperature are, have premature failure. Or the age of the batteries for the installed base, could be this, and you of your 2,500 data centers maybe have 3 or 4 data centers that have batteries that are older. So you may want to look at those. So benchmarking, coming up with what's normal and what the chances of failure are, and applying those into an AI is absolutely critical. So to wrap it up, Collaborative ecosystem starts with the customer. The customer brings the requirements, and it's an iterative process. They don't just bring the requirements. They have to give feedback as to what's going on along the way. The cloud, having everything cloud-based, when you're managing that many sites, having all the data in the cloud and running APIs is going to be critical. And then AI, being able to run AI on these systems and being warned before things are going to fail, because you're not going to have on-site IT staff to be able to look at problems. So that's what I had. Thank you very much.